Okay, I see that we are already up and running, guys. So I think that it is very nice to have you all here. I would like to welcome everybody, both the presenters and the attendees, to this event, this webinar. This is the Autonomous Ship Reality webinar. It's the first day. It's a 3-day event. So let's start. We have a full agenda in front of us. I saw from the presenters and from the titles and from the presentations that we have a very nice mixture. We have the industry here, we have the academia, we have the research community. Everybody's here, so I'm looking forward to a very, very nice presentations and very, very nice discussions. So not losing any more time, I think that we should, what we will do, the format is that we will make the presentations. You will all have like in total 18 minutes. So I will be counting the time, and when the time ends, if you haven't ended, I will notify you. Otherwise, I will ask, we will, fuel up a little bit the discussion. And after each of the presentations, if we have the time, otherwise we will go to the Q&A session at the end. So not losing any more time, Konstantinos Louzis is the first in line. And while you are sharing your screen and your presentation, Kostas, I would say that the title is "Will the Seas of the Future be dominated by autonomous ships?" Kostas has a master's degree in naval architecture and marine engineering from the National Technical University of Athens. Currently, he is a PhD candidate at the Laboratory for Maritime Transport of the School of Naval Architecture and Marine Engineering, within the research area of risk analysis throughout the life cycle of marine systems. Actually, Kostas is a member of my group, and he's doing his PhD with me. And for his presentation, he will be discussing and try to reply and try to give some interesting pointers to questions such as, what is an autonomous ship? Does it make sense for all ships to be autonomous? And is the conventional approach to managing risk adequate for autonomous operations? So, Costa, the floor is yours. Fire away.
Okay, thank you very much, Professor Vedikos. Good afternoon, everyone. Without any further delay, hope you can see my screen. Okay, so beginning, I would like to say that there has been a lot of research and development related to autonomous ships. And in fact, most of the technology is present currently, and many of the future challenges have already been identified. So in the wake of these developments, some new questions have come up. For example, does it make sense for all ships to be autonomous? Or how can we ensure these autonomous ships operate safely? So this is the main topic for this presentation. And first I would start with talking a little bit about automation in general. So the discussion about autonomous ships really lies in the broader context of automation. And the discussion about automation is really an old discussion. And it usually relates to our fears of robots taking over, which usually is not true. But the reality is that now the situation is a bit more complex due to the involvement of artificial intelligence systems. So according to IBM, automation is defined as the application of technology, programs, robotics, or processes to achieve outcomes with minimal human input. However, automation is not only about changing the technology. It is also about changing how humans interact with the technology to achieve results. And this has been highlighted by Bainbridge already in 1983. So Bainbridge says that, in fact, the more advanced the control system is, the more crucial may be the contribution of the human operator. Going to the maritime domain, the interaction between humans and technology has been researched a little bit, for example, by Lutzhoff and Decker, who investigated the role of automation in the grounding of the Royal Majesty in 1997. The Royal Majesty was a passenger ship. And they concluded that automation changes the task it was meant to support, and it creates new error pathways. It shifts consequences of error further into the future and delays opportunities for error detection and recovery. And what is really interesting in this context is that the irons of automation that were identified back in 1983 are still relevant, and relevant also in the context of autonomous ships. So what is an autonomous ship, anyway? There is ongoing discussion about how to exactly define an autonomous ship. But for the context of this presentation, we can consider the most recent definition from the IMO as being the established one. And this definition refers to two levels, actually. One is human presence, and the second one is the degree of automation. And what is clear here is that the term autonomous ships, with the term, we do not refer to robot ships that have no crew on board. Autonomous ships are ships that integrate automations to varying degrees. As I said earlier, there has been a lot of research, beginning more intensely in 2012 and continuing up to the present. So many technological challenges have been addressed. And by now, a ship we can say that it can sail mostly autonomously in open sea. And there have been various demonstrations, especially in the year 2022. So the Yara Birkeland in Norway has started operating with crew on board and will operate autonomously in the coming years. The Mayflower has completed the first autonomous transatlantic crossing. In China, we have an autonomous feeder that has sailed autonomously as a test, but also the Sunflower Seretoko, which is a passenger ship that has crossed 750 kilometers autonomously. We also have various research projects, for example, the Autoship project started in 2019. We have the Moses and the Yeast projects in 2020, and recently we also have the Seamless project that has now just kicked off. And these are just examples, and there are many more, obviously. So a lot of research, a lot of developments, but why do we need autonomous ships in the first place? The incentive initially was to alleviate human-related errors. But along the way, other benefits came to light, and these include benefits in the domain of safety, the domain of cost efficiency, and in the environmental domain. But with all these expected benefits, the question is, does this mean that autonomous ships are a one-size-fits-all solution? And should all ships be autonomous? If we look at different ship types, these operate differently, and they have different characteristics. And as a consequence, these different characteristics would make them better or worse candidates for autonomous operation. In general, we could say that an autonomous ship must be accepted and trusted by the public and the relevant stakeholders. It must be predictable in its behavior, and it must not adversely affect waterway safety. So, although this is definitely not an exhaustive mapping, we could take, for example, the payload type. Payload type may affect public acceptance. For example, a tanker ship that carries crude oil or a passenger ship may not be trusted by the public to carry such valuable cargo. Then we have the trading pattern. Trading patterns may affect the predictability of the route. Fixed routes may be a more controlled environment for fully autonomous operation. Then we also have size. So bigger ships often present more potential for harm, for example, in terms of environmental impact or loss of life. And therefore, this may affect public acceptance. So the public will not accept large losses in case of failure. Finally, where the ship operates also affects predictability in terms of behavior, as well as the safety of the waterway. So in open sea, where there is sparse maritime traffic, autonomous operation may be less dangerous compared to a coastal area where, for example, we may have unsafe interactions with smaller conventional vessels. So in the research and development throughout all these years, there have been various business cases that have been examined. And it seems that the most promising cases involve relatively small ships that operate on fixed routes and that carry a payload that does not present significant potential for harm. So there's a lot of focus for cargo ships in carrying containers, for example, or there's also focus in maritime drones used for research purposes. However, in urban environments, there have also been some promising cases, such as the auto ferry in Norway, which carries passengers across a canal, or the rowboat, or even autonomous drones that will carry passengers in the 2024 Paris Olympics. So again, these are just a few examples of business cases. But even for business cases where autonomy makes sense, we still have to ensure that autonomous ships will be safe, and at least as safe as conventional ships. And in fact, perceived safety is one of the most significant concerns and is inversely proportional to autonomy levels. So a survey for autonomous urban ferries found that people mistrust fully autonomous ships and would trust less autonomous ships more. So the conventional approach to risk is mainly based on identifying accident scenarios, and even newer approaches are based on this very fundamental idea. After identifying accident scenarios, risk is quantified as the expected consequences from these accident scenarios. And again, we have a very old idea from Kaplan and Garrick in 1981, where risk is described as a scenario that is attached to a probability of that scenario happening and has some consequences. So this is the basic understanding. And this works fairly well, has worked fairly well for cases where we have adequate knowledge of how the systems work, we have operational experience with failures, and there are also failure and accident data available that can be used for calculating probabilities. So for conventional ships, this has worked well. But for autonomous ships, which have only been tested in small scale and are also infused with artificial intelligence, we don't really know what will happen exactly. And although many studies have assumed that autonomous ships will be exposed to the same as conventional ships, this will most probably not be true, because the systems become more complex and include new interactions, and autonomous ships will likely need to interact with conventional manned ships in mixed traffic scenarios. So, does this new hazard environment and the new hazards we face mean that we should replace our risk assessment approach? Actually, no. But the point is that we cannot only rely on trying to identify scenarios for accidents that have not yet happened. So we need to come up with new complementary techniques that will complement the established techniques for risk assessment that will take into account the complexity, of the new ships, the fact that autonomous ships are part of a system and they interact with other things, the fact that autonomous ships will have to collaborate with humans and share risk awareness, and the fact that there are no available data and knowledge is currently limited. So we need to go beyond calculating accident probabilities. So closing, so will the seas of the future be dominated by autonomous ships? The consensus is that most likely no, this will not be the case. Current understanding is that autonomy will be application specific. So we'll have different maritime segments with different requirements that will have different applications for autonomy at different levels. But in any case, autonomous ships, to varying degrees, need to be safe. So thank you very much for your attention, and if there are any questions, I will be very happy to answer them.
Thank you, Kostas. Thank you. I have already posted a message on the public part of the chat, and I most welcome and we expect interesting questions from the audience. We have a quite big audience, as I can see in the upper part of my screen. So I haven't received any question yet. So let me just ask you to elaborate a little bit on the fact that when we're talking about autonomous ships, are we merely talking about ships without crew, or what kind of big changes we are expecting towards an autonomous ship and designing an autonomous ship and operating an autonomous ship?
Okay, thank you very much for the question. No, I think the current understanding is that no, autonomous ships are not ships without crew, but they are ships that integrate, that automate various processes to various degrees. And this will definitely have an impact on how ships are designed, and most importantly, how ships are operated. And with respect to safety, I think with how risk is managed in the operational sense, because it will be completely different if we have people on shore thousands of miles, potentially thousands of miles away, trying to mitigate the consequences of some kind of failure in an emergency case, but also more typical, more routine operations will have to change. For example, routine maintenance will be very much different. And this is true also if we have no crew on board, but also if we have reduced crew on board. So yeah, I think that's the idea here. Thank you very much.
Thank you very much. That's an interesting reply. I believe I fully agree with you that things will not be that as simple as some people, expect or present. But let's see how this will evolve. I have already started taking some questions on the Q&A part, but I think that we will continue with the next presentation, and we will come back to the questions later during the process. So thank you, Costa, very much. And now it's time we proceeded with the second presentation of the day. It comes from Carl Johansson from Abacus, and the title is Efficiency and Impacts of Level 2 Autonomy Navigation Systems. Carl, I see you have already started. So for the bio of Carl, it's over a decade that he has worked in the forefront of marine technology. Since 2016, he has been leading cutting-edge autonomous shipping at some of the largest marine companies in the world. He is indeed a strong believer that autonomy will disrupt and define the marine industry for decades to come, bringing a safer, more efficient, and even more human future. As VP of Business Development in Abacus, his role is to be the bridge between the autonomous technology and the real world applications. Now, in his presentation, he will be discussing the current capabilities of the Abacus system, how they will impact the operation of the ships, how autonomy can support new regulations such as the very famous CII, and how the next generations of autonomies will change shipping forever. Um, Carl, we are more than eager to hear you, so the floor is all yours.
Thank you very much for that introduction. Can you confirm you can see my screen?
Yep, everything is fine.
Thank you. All right, so hello everyone. So as you heard, I'm called Johansson, and in this presentation, I will tell you about what kind of current status is of autonomy and what benefit you can have from autonomy already today with the current systems. First, I will say a few words about who we are at Avicus. So we are a startup that's specializing in autonomous navigation solutions. We're fully owned by HD Hyundai, the world's largest shipbuilder. And even though we are a new company, we are actually a result of 11 years of research and development into autonomous shipping by HD Hyundai. As the only company in the world, we are actually focusing on autonomous navigation for all types of vessels, from large commercial ships to very small leisure boats. And we strongly believe that we can help ushering a new era of marine vessels, which are safer, cheaper, more efficient. We can combine the strength of human crew with the strength of autonomy. So you see here autonomy levels. You've seen a similar one in the previous presentation. There are a few different versions. We like to use this one that's from the 1C ecosystem. So they all work about the same way. You have the low levels, which has a high human interaction and a little bit lower autonomy interaction, and they go all the way up to the highest level where you usually have the fully unmanned autonomous ship that doesn't require any human intervention. At Avicus, we're currently focusing on the lower levels, and we're doing that because we would like to provide benefit of autonomy now to the industry. We're not trying to chase a future dream where which honestly neither the market, the customer, or regulations are ready for it. And we really see a lot of value in these lower levels. And for example, they're focusing on enhancing the crew capabilities. So we're not really replacing any crew at this point. But they require no change in regulations. It can still provide a lot of benefits such as enhanced safety, improve economy, and reduce emissions. We're getting back to these a little bit later in the presentation. Maybe the most exciting thing is they are actually available with today's technology. So at Avicus, we have a system called HINAS, and we actually sold over 300 level 1 systems, and I think 25 or so level 2 systems. The difference between the level 1 and level 2 is level 2 is actually autonomous control of the ship, while level 1 is more of a passive object detection advisory system, you can say. And for us at Avicus, while we focus on these level 1 level 2 systems, we do that because we also have stepwise approach to autonomy. Each level has a lot of benefits that can be realized today, but also learnings for us. We build a foundation through getting more data, more market acceptance, and knowledge. And then we take a step up and up and up when we know the market and the technology and regulations are ready for it. I would like to start a bit here with showing you a really cool project we did last May. We have our HINAS 2.0 system. We consist of day and night cameras, sensor fusion of camera, radar, AIS, etc., object detection and object classification, autonomous navigation, collision avoidance, all color compliance, of course, route and speed optimization, etc. We took that system, we put it on an LNG carrier. We then sailed across the Pacific for the first autonomous trans-Pacific voyage. We sailed over 10,000 kilometers, 350 hours, non-stop with autonomous control, new human interaction. Of course, we had the crew on the bridge observing, but actually 350 hours is 2 weeks, 24/7 of no human interaction with the ship. And it worked extremely well. We had well over 100 collision encounters, and the ship took the right decision every single time. Another interesting finding was that we actually had reduced the fuel consumption by 7% through speed and route optimization, which is a quite significant number, of course. And the really cool thing is this system, the Highness 2.0 system, is going to be standard on all new build ships from HD Hyundais, hundreds of ships per year, and we're going to start later this year. So here we really have some autonomous ship reality happening. About the benefits you can see from a system like this, from a safety point of view, we know, as you heard also in the previous presentation, the majority of marine accidents are caused by human errors. And when we're adding object detection, autonomous collision avoidance, we can see a significant reduction in that. And because our system is still an assistance system, tools like sensor fusion, augmented reality, where the crew can see all sensors and instrument on the same display, will help it focus and reduce accident even more. We're also adding new capabilities such as night vision and unique perspective as the kind of 360 top-down view, as you can see on the video below. From an economy point of view, I already mentioned possibility to optimize your fuel consumption. We're actually seeing we're testing on multiple ships that we get somewhere between 5 and 9% quite consistently. And that is in line what we can see from academic research also. So that's a really, really great benefit, of course. We also remove uncertainty during the operation. We can constantly do small improvements and adjustments to our course to always be just right, instead of doing the bigger maneuvers usually a human crew is doing, which is much less efficient. We will also have, we can say, kind of the best crew all the time. And I'm not indicating that our autonomous system is better than any human crew, but any improvements you're doing on one autonomous ship, you will deploy to the full fleet. So there's no difference between one ship to another. Another really cool thing we discovered is the simulations we're doing is matching up much better with reality if that reality includes autonomous navigation. It'd be much easier for us to predict and doing optimization models with autonomous navigation in comparison to the bit more varying and uncertain human control. Mm. Another topic which is important, but it's still a little bit early maybe, is insurance premiums. We are talking with insurance companies, and we are seeing that there's a very strong possibility that we get significant reductions in insurance premiums, which is the systems like level 2 autonomous systems, like the Highness system. Mhm. Even though it's still a little bit way into the future that will happen. From an environmental point of view, of course, very important for everyone. We're seeing an interesting number that accidental oil spills accounts for 10 to 15% of all oil that enters the oceans. Because we have a autonomous navigation system that is increasing safety, we will have fewer accidents with least fewer oil spills, and of course other toxic spills, because when you have an accident, it's not just oil that enters the oceans, it's a lot of other nasty stuff. From a regulatory point of view, the autonomous system can very easily adapt to local regulations, as we see a lot more local and quite small areas of regulations, like environmental protected areas, etc. And with an autonomous system, it's very easy to adapt for that very quickly. We also have support in compliance tracking, not only documented things that have been done incorrectly, but also adding, as we have features from black box solution, we can go back and see what happened in this scenario. Because of the situation awareness that the system generates, you'll be able to get a much better content for learning and training and improvements for the future. And as mentioned, we have the very interesting CII and hot topic, the carbon intensity index, and actually have the next slide dedicated to that. I'm going to skip it for this second here. And when you have efficiency improvements in fuel consumption, you will also have improvements in CO2 emissions. And we're seeing about the same numbers, 5 to 9% here. And in fact, an autonomous system like our Highness system is one of the most efficient way to reduce your emissions. If you compare it to other popular ways, for example, rotor sails or air lubrication, the cost per percentage emission reduced with an autonomous system is a fraction of the other, a lot bulkier system. You can of course have all of these three systems on your ship, and you get even better improvements. So no restrictions there. But if you only would have one, the most economical would be an autonomous system. So the CII, if you might not be fully aware of what it is, I'm just going to quickly explain it. It's basically a measurement of the efficiency of marine transport in terms of CO2 emission. And it's mandatory for all from this year for all ships above 5,000 gross tons. It generate a rating for each ship from A to E, and it's set annually. This rating actually gets more difficult every year. So ship owners will have to improve to keep the rating and improve their existing ships. In the case you have a low rating, you're running risk of fines, forbidden to enter ports, losing customers, high insurance premium, reduced resale value, etc. So quite serious consequences. So we see autonomy can support this. Of course, even a level 2 system, as I mentioned, we have reduced emissions. That actually is pretty much one full, say, CII rating level. So it's a great start already there. Also, will add a lot more predictable navigation, which is important because this is an annual measurement. So you have to understand what your future rating could be based on the simulations, etc. It also has a quite interesting feature if compared to human crews. So humans, as we know, are tending to favor short-term benefits over long-term benefits. For example, avoiding being late by using a little bit more fuel, get higher speed, and therefore getting a bit higher emissions. In contrast to looking at the long-term picture, which that might actually negatively affect your CII rating. An autonomous system can do the long-term calculation, long-term planning, without being biased towards short-term benefits. And of course, it can very efficiently track and also target specific CII levels. And a really cool thing, the HINAS 2.0 system will actually be the first autonomous navigation system in the world to have integrated CII tracking and targeting, something we're releasing later this year. We're very excited about it. To sum up, with the Avicus HINAS 2.0 system, we have actually commercialized autonomous shipping. When you're putting one of these level 2 systems on your ship, you have an autonomous ship. It's not an unmanned ship. It's not, it looks the same from the outside pretty much, but you have autonomous shipping. And you're getting great benefits already with these levels. As we mentioned, you have improved fuel consumption, you have improved safety, you have environmental benefits, and you can track and target new regulations. So for our perspective, the autonomous reality is that it's happening right now. It's not a future concept as many talking about. You can have an autonomous ship right now. We think that is really going to impact the marine industry over the next few years. Thank you very much.
Thank you very much, Carl. At this point, let me just say that it seems that our autonomous ship reality day one evolves very nicely. If for the presenters, we've heard very nice presentations. I see a lot of questions on the Q&A. Let me just say that Kostas has already started replying in some of them on the Q&A platform. And please, for all the audience, for the members of the audience, just please note and mention to whom the question is so we can get some and gain some time. But we will come back at the end of the after the presentations at the Q&A session, where I will pick some of them, the most popular of them, and discuss them and talk about them with the presenters. Now, having this presentation from Avicus, let me just say that the organizer team today is BS, and there are special thanks for this day, for day one, to Avicus and Seajob Naval Architects, the sponsors of this process, and of course to Mass World News team for the media support of this event. Now, let me just also say that, Carl, I understood that this Hainas 2 system is a decision support system, or it's an autonomous package, transforming a conventional ship to a autonomous or to a semi-autonomous ship.
It's both. It does indeed control the ship, the navigation fully, but due to current regulations, it you still have to have crew on board. So it's supporting the crew with autonomous navigation.
And I saw also somewhere that you were saying about tracking CII, something like that. It was the previous or the slide before the previous one. So can you elaborate a little bit with CII how you can, get a better rate for your ship?
Yeah, because sure. The autonomous navigation system, of course, it's it's very aware of what's happening on the ship all the time, the fuel consumption and your path planning, much more than you will have from a passive system that would be making navigational decisions. So it can optimize the speed and path to basically hit a specific emission level, which is the same thing as a specific SAI level.
Okay. This is clear. And as a last question from my side, can you a little bit elaborate also on the fact that you said that the system is not, it's a best crew, but it's not better than the crew. Can you a little bit elaborate, because this is a continuous discussion about, the employment and how autonomous ships or the introduction of various autonomy levels on board ships and autonomous operations on board ships can, affect the crew sizes and also in the kind or the type of work that the crew are conducting on board the ships.
Yeah. So, as I said in the beginning of the presentation, this is an assistance system that supports the crew on board. This level 2 autonomy is not supposed to replace any jobs. I said that our system is not necessarily better than every single crew in the world. We're not going to pretend it's 100% perfect. We're improving all the time. We believe it's better than the average crew, I would say, even though it's a pretty strong claim to make. But there are always improvements we can make. So that's why I said that. And I think the statement was that you will always, when you make improvements on one ship, when you have an autonomous system, it will be automatically deployed to all other ships you have with autonomous navigation, which is when you have a human crew, you have to go through quite a long, lengthy training process to get all your crews up to the same level when you're finding new optimization models.
Okay, thank you. Thank you very much, Carl. Thank you for the very interesting presentation. And thank you for sponsoring also day one of autonomous ship reality. Another question. What kind of ships have you, on what kind of ships have you, or types of ships have you installed the system?
We primarily is larger cargo vessels because of our connection to the HDR Hyundai, but we've also been on tugs, on all the way down to small leisure boats also. It's a slightly different system, but the same algorithms actually. And yeah, different cargo vessels, and we're looking into ferries and a few others. But the majority of our current install base is larger cargo vessels.
Thank you. Thank you very much, Carl. And I think it's time. You can also check on the Q&A if you think that you can reply to for some of these questions. Please go ahead, and as I said, we will go back towards the Q&A session and pick some of them so that we can discuss them, and you can all have your opinion expressed on this question. So thank you very much, Carl, and we are ready to proceed to the third presentation of day one. The third presentation will come from Kenneth Johansson. The title is Making Room for Autonomy in the Real World. Now, waiting for Kenneth to share his screen. I think that we can say that he's an interaction designer at the core, but has expanded into management in the later years. Kenneth had over a decade of experience as a software distributor before he went into the shipping business 5 years ago. And his background as a floor manager in an IT development company and later CEO of a software development company. So he knows how to make actually systems and this kind of systems to work. He is also a board member of a Norwegian consortium aimed to set future rules for autonomous vessels. So before starting your presentation, I would like from your, Kenneth, from your CV, I would like to ask how do you see, these rules and regulation for autonomous ships, whether there will be a no-go or go, aspect of the whole thing. Yeah.
Great question. Thanks for the introduction. Yeah, what can I say? I like the levels. We need to see this in levels. Some levels will be easy. Other ones would maybe never reach the finish line. I will actually touch slightly on some of this in my presentation, but it's a big question that needs quite some time to answer.
Far away, the floor is yours, Kenneth.
Thank you. I assume you see my screen and hear my voice and everything, so I'll just shoot.
Yep.
So, hi everyone. Thanks for letting me speak at the Autonomous Ship Reality Conference. I'm representing North Sea Container Line, or NCL for short. We operate a fleet of container vessels going between Europe and the west coast of Norway. I wanted to share some thoughts on the autonomous future ahead for us at NCL and what we've done so far. So, we already learned about me. Some of the information, as you said, it sounded quite grand when you said it. I'm Kenneth. Before I did NCL, I did certain different IT companies. I was a CEO, as you mentioned, and was enrolled into NCL to change the future for them. I'm working on digitizing and optimizing all of NCL, all the way from paperwork on a booking level to the actual planning of cargo movements and navigations of vessels themselves. I'm a father of two tech enthusiasts, avid leisure boat captain, and motorcycle rider, and I deeply care about how people use systems and gadgets and light switches and maps and all of the things they use. I want to know how it works and how I can improve it if I can improve it. All right, back to NCL. We operate container vessels like you see here, and we've been operating container vessels since 1994. The vessels run between Rotterdam, Hamburg, and Bremerhaven, and all along the west coast of Norway. As you can see from this picture of NCL Salten, we run vessels with cranes, which in turn makes us able to serve keys without much infrastructure. We can do the entire cargo operation from the vessel with our own crew. A slightly better view from the port here, where you can see how we have the ability to operate cranes. Slight note on this picture, if you can see the cabin all the way on top of the crane, that could prove useful later in my presentation. But enough about these vessels. These vessels are not the future of NCL. These are. We are currently building 2 new vessels that will serve our trade. They are built for us especially and will be a game changer when they set sail for Norway. We have redefined the cargo operation with them, even though they are based on the same kind of open-top design as you saw with NCL Salten and Svelgen. They're still quite different when we're working with them. Some details about the vessels on screen. It's a 1,300 TEU, has 350 reefer plugs. There's room for 445-foot containers. It has 2 cranes on board that can serve all the boxes to the port or to the quay on either side of the vessel. And maybe most important, we don't just talk about the future, we act on it. We create sea change in the industry and will achieve the IMO 2050 CO2 emission goals in 2025 with these vessels. They will make a big impact when they hit. And could you guess what's the number one question I get about these vessels as CTO in NCL? Are they autonomous? Well, no, they're not. Will these vessels be sailing autonomously when they arrive in 2024? No. Have we built them to sail autonomously after some years? No. Have I gotten a million questions if they're fully autonomous? Yes. Now, will they ever be sailing autonomously? Maybe at some point, but maybe there's way much more we need to do before we make that step. And I get the point, honestly, from all the ones asking, why are they not autonomous? Sailing a vessel, how hard can it be? Easy as 1, 2, 3, right? Well, the fact that these vessels are 150 meters long and keys are not, and weather at the Norwegian coast, which is often windy, and right now it's snowing, and all the other vessels surrounding them, and the communication and the mooring and the, okay, maybe a bit complicated. But a single person can do it, right? We can cut him and we can save costs. And people make mistakes, right? We heard the 70 to 85% accidents by human. So removing them from the equation, we get less mistakes, right? But my question is, do we actually have comparable data for this? We don't have 20 years of vessels being run by computers. We don't know what kind of errors they might make. So it's easy to say, compared to nothing, it will be better. And also, if people make mistakes, are those only committed when sailing a vessel in the heat of the moment? Do we never make mistakes when we plan a system for sailing or when we code autonomous systems? After more than a decade in the IT industry, I won't say what I think of the last one, but accidents does happen all over. More importantly, our vessels are in port 50% of the time. When they're sailing, 2 people can operate them, but they're floating factories. When they are in port, we need way more people to handle them. There is a huge potential for autonomous technology. We do not want people in these areas, on the ship, on quayside, next or even below a crane, next to this reach stacker. We can move to cranes being more autonomous. Communication between crew and stevedores could be automated and upgraded. We could automate planning between ports, and we could automate all communication. I could spend hours on this slide alone because this element of our operation has a huge potential for automation and autonomous technology. We already started, but there's still a lot to do. But just imagine that this vessel could actually tell the crane or the cranes on board where this autonomous reach stacker needs to go to pick up all the containers. And this could be then communicated in real time. That would be something. Then there's the slight problem of communication. The only port we communicate via API is a small port just south of Kristiansund called Kristiansund Base. That's it. In the entire network we're running, this is the only port that autonomously could handle changing load or discharge lists. That's a huge problem for getting vessels smarter. If no autonomous vessel could call a port unless someone manually told it to, how smart is it really? We at NCL are dependent on communication with ports as we do not operate any ports on our own. Let's all move on this topic. We need to get things done in this area. To be more efficient and to streamline, we all need to move forward. Same with better fuel alternatives. Our methanol vessels will do some, but not all. It's a start, but we all need to move together. It makes sense to get a small ferry crossing a canal smarter. It makes sense to automate repetitive tasks. And as mentioned, you can get the best crew if you put them in a remote control center and make them operate several vessels. But let's not forget to look at the scenery while we're rushing for the goal. We might pick up something along the way that's worth looking into. Autonomous sailing or not? Which moves me to my big question. Let's list the benefits of sailing a large intercontinental container vessel autonomously. But there is a catch. You can't use cost saving. What's the actual benefit? Why are we doing this? We need to apply standard software development techniques to the autonomous development we're seeing now. Seems we're rushing towards self-sailing vessels, self-mooring and all the works. But did we stop and check if this applies for all waterborne transport? Just because a company invented a genius radar that could identify if a building is built of concrete or wood, would it still be smart to spend a lot of extra money on putting it on the vessel? Or should we turn around and see if it's a problem for ocean-going vessels to identify what buildings on land are made of? They shouldn't be on land. That's my stand on the autonomous sailing. Tell me why I should, and I probably will. And yeah, I know obviously this slide is a bit on the spot. There are rest hours, gathering of crew, etc. But you get the point, right? Another obstacle for autonomous vessels are who we are selling this to. There are very few tech enthusiasts in the buying end of logistics products, but there are a lot of skeptics. Why should we spend a lot of money in building autonomous vessels just to cut out some personnel? Selling this is all about the cost in the end, unfortunately. What do I need to pay to get this service from NCL? Will I pay less for an autonomous vessel, or will I pay more? I find it surprising that the cost of running an autonomous system is not considered into this equation most of the times, at least when it's presented to us. Will this system or software run on free servers, with free maintenance, with no need to be updated? It would just be way cheaper than having a captain on the payroll. I'm afraid that it won't. We will just move the cost from personnel to some cloud partner, and the bill in the end is the same for the end user, the one that buys movement of some kind of cargo. To me, the cost-saving argument is not enough. Identify risk saving, less emergency, safer work environments. To me, operating container vessels, these factors are not identified during sailing, but during cargo operations. By today's standards, of course. But tell me how wrong I am on this, and let's get moving together. I love to apply technology to fix problems. But the technology should improve on the solution, not just remove people and deliver the same result. Of course, some areas are explored already, such as the digital twins we got going for vessels, where we can simulate sailings and cargo operations, providing us with info it's hard to calculate on our own, since there's so much data to process. With a digital twin, we could have 100 sailings to find the optimum route for the cargo we've planned. That digital vessel will, of course, sail autonomously. There is no one at our office with a PlayStation controller doing these 100 sailings in real time, but it will base its calculations on a manned crew, which then, after the simulation, will do the actual sailing we planned in the ether. We got cargo operations going into operational system in real time. We can then calculate when we're done and how the schedule looks. And what this also does, that's not a direct action, but all cargo planners can now be on shore, and that task could be removed from the vessel. The task and the person have been sent to the remote control center, so to speak. Okay, this does not make headlines, but it does make sense. All of these underlying systems are feeding our customer portal, who then can feed information to our customers directly. Can we still say that we use AI and autonomy, even though the vessels are sailing the traditional way? I will say yes. And that's not just because we have built in funny quotes by ChatGPT in our internal systems, but it is because we look at our operation as a whole. The slots on board are booked in, the vessels sail, and they do their cargo operation to get the cargo where it should go. All of this is analyzed and calculated against automation and autonomous operations, not just the actual sailing of the vessel. We are long for the ride towards autonomy, headed for the destination, but we at NCL are sure to make detours along the way if that can give us value. Will NCL be at the autonomous finish line later than others? Definitely. We will not be the first ones with an autonomous vessel. That ship has already sailed, pardon the pun, but maybe we will pick up all the good stuff that could make the journey even better along the way. And who knows, maybe our experience could be even better in the end when we're all gathered at the final destination and we share our stories around the campfire. We learned and adjusted along the way. Or maybe we're just late to the party where everybody else has a self-dancing robot and we just learn to floss. I do not know where the autonomous future lies for us right now, but I know there are definitive areas that we will make smarter and more efficient using technology and autonomy. Maybe the vessels will be fully automated sometime in the not so distant future. I don't know, but I'm looking forward to finding out. Let's just not focus on purely sailing, but all the other stuff all the vessels around the globe are doing. That's it for me. Thanks so much for having me. If you would really like to tell me how wrong I am, please find my contact info on this slide and use the Q&A as well. And I hope this can be a start of a good discussion with a lot of you out there. Enjoy the rest of the conference.
Thank you, Kenneth. Thank you for your contribution to this conference. It was a very nice presentation. Very nice indeed. It was. We are also intrigued, and we are also trying to work on, on the ports that will be receiving autonomous ships and what changes this entail. Can you elaborate a little bit on that? I saw that you touched upon that at the beginning of your presentation.
Yeah, there are plenty of factors that will drive it. We, of course, are the ones that pay for it, so we need to make something work for us as well, not just pay for the technology. But I would assume, same as with the graph I showed you, the enthusiasts are where we're at now. We haven't broadly gone into the global community and haven't settled this, right? So we need to get the enthusiast first and then move to all the others.
Yeah, very nice. And may I ask now? I pick a question from the Q&A. As I said also to Kostas and Carl, you can also reply to the questions addressed to you or to any question that you find interesting in the Q&A. But it goes very nice and very nicely along with what you said. It says that it comes from Surab Kumar, and it says that most of the autonomous technologies and studies are focusing only on the navigation part. Unlike cars, ships are a complicated set of systems. It's a big system, system of systems, which technologies, pathways are available to automate day-to-day operation, maintenance, safety, security aspects, and this kind. So it's not only navigation; it's a whole package there. What's your thoughts on that?
That's the thing we need. We can't just focus on sailing a vessel. We need to focus on the broad operation that a vessel could do. Maintenance could be something that could be automated. The vessel could tell when it needs an oil change, just to put it on the spot. There are, of course, different weather conditions that a vessel could handle autonomously to help and aid the crew. Of course, there are huge area we could discuss on this, which I can't fit into 15 minutes presentation. But my main concern is that it seems like the general consensus is to get the vessels sailing on their own, and we kind of left behind all the other stuff that's happening.
Okay. And you are operating container ships, is this correct? What other types of ship you find, kind of eligible for, adopting autonomous levels of operation rather quickly?
Well, the milliampere shown by Konstantinos, which is fun one, up in Trondheim, a small ferry crossing a canal. You can push a button and it comes and picks you up. And having that autonomous, it can go all day, all night, all times. Obviously, you have to get some kind of control center, etc. But the scale you can get on this really grows. And that also in autonomous operations for us, if we could make the crane semi-autonomous and move the crane drivers into a remote control center, they don't have to sail. When they're sailing, we don't use them. So they could then just switch to another port on the screen and do that operation instead, right? So obviously there are vessels that benefit from being autonomous, and my vessels could as well. But from my point of view, there's so much more I would like to do before I start doing that.
Okay, just as a pointer, just check the Moses and the Aegis project, because they are dealing with autonomous cranes and autonomous ways of operating the crane. It would be nice.
I'm the work package leader of one of the Aegis.
Oh, the Aegis, okay. Very nice, very nice.
I have heard about it.
Kenneth, thank you very much for your presentation. I think it's time, and as I said, please check on the Q&A. If you find the question interesting, please go ahead. And so I think that it's time for Rolf now, Rolf Hitstra. The title of Rolf's presentation is Novel Autonomous Shipping Concepts minimizing overall cost and environmental impact. As I mentioned, SeaJobs Naval Architects is one of the sponsors of this first day of the conference. Now, Rolf started his career in the maritime industry back in 2002, first at major Dutch shipyards, and since 2017 at SeaJobs Naval Architects. He is the autonomous shipping expert at the firm. With a background in the field of ship structural design and analysis, he quickly realized the game-changing possibilities exactly that could bring in the early days of this topic, particularly what it could mean in terms of sustainability gains. Now, on his presentation, he will be discussing about the autonomous low-energy replenishment dredger, ALERT, and the autonomous guard vessel, AGV. These are two of such designs that with their own innovative maritime operations. Feasibility studies will also be presented, and they were performed, that include CAPEX and OPEX analysis and the first estimation of their environmental footprint in terms of the Dutch environmental cost indicator, the well-known MKI value. So, Rolf, the floor is yours, and we are really expecting a very interesting presentation from your side. Thank you very much.
Okay, thank you for the introduction. I think my screen is visible. Is that correct? Yeah.
Yes, everything's fine.
Okay. Yeah, perfect. Well, good afternoon, all. My name is Rolf Hydra, working as an R&D consultant within SeaJobs Naval Architects. I'm the research lead within SeaJobs in the field of autonomous shipping, founder of the ALERT concept, which is displayed in the screen. And finally, I also had an advisory role to the Dutch government in setting up the technical requirements for drones on the Dutch inland waterways. During this presentation, I would like to show the vision of SeaJobs towards autonomous ship designs, which I will do alongside two of the concepts which were mentioned, the AGV and the ALERT. First, I would like to introduce SeaJobs shortly. Well, SeaJobs is an independent design and engineering company, and we serve both ship owners as well as shipyards, which we do worldwide. Therefore, we also have 7 offices located all around the world. And all in all, we employ about 200 engineers. They are involved in the ship design, from the concept design until detailed design. We also do some yard support services, and since a couple of years we have a dedicated R&D department. And there we focus on energy, on data science, and finally autonomous shipping. Well, in relation to autonomous shipping, we developed a vision, and basically this was based on early studies which we performed, where we found out that there was a lot of research performed towards regulations of autonomous shipping, on the autonomous systems, navigation systems, but there was hardly any focus on the ship design in itself. And therefore we set up this vision, where we feel that we can enable a competitive and sustainable maritime industry, basically by using the full potential of autonomous shipping, where we start basically the ship design from scratch and optimize the core operations of the vessels which we design. And this is also what we did for the concepts which I will highlight on in a couple of minutes. So Speaking about autonomous shipping, the application of autonomy, we see it not as the goal in itself, but there are higher goals which we can reach. First of all, this is related to the energy requirements of vessels. We think that we can significantly reduce these energy requirements. By that, the application of sustainable energy supply becomes easier, volumes and mass related becomes less, and also the related costs are being reduced. So all in all, this creates a cost-effective and sustainable solution for shipping operations. Next to that, we feel that human safety and let's say the shortage in crew, which we feel these days, that can be an important benefit for this kind of vessels as well. Well, to show some example of concepts which we developed over the last couple of years, I'll start with the alert concept. Where the alert is the autonomous low energy replenishment dredger. CEJOB has dredging as one of the focus markets, so we have quite a track record there. Basically this is also the starting point for this development. So we consider a conventional hopper dredger, a surface vessel, which we create for autonomous operations and unmanned operations. It becomes less complex to perform subsea operations. Having this in mind, we set up this initial sketch, which is shown in the screen, and this was the starting point of the continued development of this concept. And basically this was considering some benefits which we saw of the submarine application, since in transit condition such a submarine experience less wave resistance and herewith reduced propulsion power. Second, the suction head of the dredge pump becomes less, simply because the vessel is operating near to the seabed, and by that the dredge pump needs less power. All in all, this leads to a reduced energy consumption, which is beneficial. But we also see that the operability window of the vessel becomes larger, which is related to the wave-induced motions, which become less. So the vessel can operate in a higher sea state. We envisioned a sustainable energy supply, and by that we feel that we can create a cost-effective and sustainable dredging solution. If I show some of the highlights of the design, of course it's a special hull shape dedicated for submarine operations. We applied a redundant propulsion system, so we have two asymmetric thrusters in the back of the vessel, two tunnel thrusters in the forward area, and by this we have a highly maneuverable vessel, which is important during dredging operations. And second, since the unmanned autonomous operations, it's important to have redundancy in the propulsion train. Then we have another aspect of the design, which is interesting, since we optimized the cargo hold, which is called the hopper. Due to the lack of accommodation on board, there is more space to extend the length of the hopper, and by these means the overall hull girder loads are being reduced, and herewith the steel weight. By that, again, the vessel can decrease a bit in size and displacement, which is beneficial again for the energy demand. Well, we performed a comparative study between a conventional dredger and the alert concept, where we found out that the total energy requirement for the Alert is only 1/3 of the conventional vessel. And mainly this is related to the propulsion and dredging energy demand. Second, we performed a quick scan life cycle assessment to get an idea on the environmental cost of the vessel. And it appeared that these are reduced by 83% compared to the conventional vessel, which is of course a good a gain for this concept. Finally, we made a capex opex study, again comparing the conventional to the Alert concept, and we found out that we have a reduction of about 25% in the total cost per cubic meter dredged soil, where the benchmark was a given cost level by the Dutch government, which we compared to a battery-powered Alert and a hybrid-powered Alert, and both appear to be very cost-effective. So here we see that there is an interesting gain for applying autonomy, both for the financial perspective as well as the environmental impact. Well, this is the Alert, quite an extreme example, I must say, since it's directly a submarine. However, this can also be done at the water surface, and that's basically the second concept which I would like to highlight on, which is the guard vessel. This project was started since we acknowledged that the current operational guard vessels, one of them is shown here in the screen, they are quite outdated, quite large vessels, highly powered, and quite some crew on board. And we felt the need to create a sustainable solution again with less crew on board, especially seeing the fact that the operations which are carried out are quite dull and repetitive. So to attract crew for these vessels becomes quite difficult. So again, start with personal guards, create an autonomous unmanned operation. We saw that the main dimensions of the vessel could be reduced, which has a benefit in the resistance and by that the required propulsion power, and also the energy consumption is being reduced. Applying a sustainable energy supply by means of batteries, again we found this cost-effective and sustainable solution for guarding of wind farms. We developed the concept basically based on an actual situation where a wind farm is located in front of the Dutch coastline, which is shown in the picture. As you can see, there are traffic lanes quite nearby the wind farm, and we took a general cargo vessel in consideration which had a malfunction which caused a potential colliding course with the wind farm. Well, to let's say we applied a mitigating action by putting these guard vessels in the neighborhood of the wind farm. And the way we did it was by having 3 of them located in the wind farm, and a reserve one, which is basically traveling up and down to the port for charging of the batteries. By considering the parameters as shown in the table, in distances and speed of the colliding vessel, we determined that the intervention speed for these vessels was 15 knots. And based on that, we found out that the required propulsion power was about 100 kilowatts. If we then consider the batteries with a 25% reserve capacity, also a maximum depth of discharge of 80%, we found out that we need almost 400 kilowatt hours of battery capacity. And basically this was the starting point of the creation of the hull design, which is shown in here. Basically what we see here is a relatively simple and task-specific vessel. You could say it's a floating monitoring kit with, of course, several batteries on board. We had one requirement that the vessel should be able to be transported in a container, which is possible, as you can see in the screen. We performed this CAPEX-OPEX study again, and it showed that the AGV operations equal conventional operation seen from a financial point of view. Of course, we have here a situation where we have limited crew requirements, there is reduced human risk, and we have a fully sustainable solution again. In conclusion, we feel that autonomy in shipping is technically feasible. We see that legislation is very important, and also we see that this is luckily in development. We feel that it's important for ship owners to have a promising business case, and we think that by performing this kind of feasibility studies, as we did with these concepts, that's very important to do. And we strongly feel that the design which is used for these kind of feasibility studies should be dedicated and basically start from scratch. Finally, CJOB foresees a competitive and sustainable future by the application of autonomy in shipping. I'm curious to hear whether there are any questions.
Thank you very much. Very interesting presentation. Those are both, they are concepts. You have not started building them, or they are design concepts. Is this correct?
Yes, indeed. These are concepts, and I must say that the alert concept was chosen by the Dutch government for a program because they were highly interested in the solution which we provided. So we have been in a program to continue this design basically. However, it's still in progress.
Have you also checked about regulations and what you should how this will be dealt with no crew on board and all that stuff?
Well, especially for the submarine, the alert concept. Well, seen from the Dutch regulations, which are currently in development, we see that this is still quite a challenge, I would say, because submarine operations are still special in that sense. So I think there is still quite something to do.
Yeah, and I heard at some point that I think it was for the alert concept again, that you mentioned that you conducted a life cycle assessment and you had a very big reduction, like 83% or something like that. Did I hear correct? Did I miss something?
Yeah, no, that's correct.
Can you elaborate a little bit on that, on the life cycle assessment that you've done?
Yeah. Well, basically, this was carried out by a specialized company in this kind of quick scans. And basically what was identified is that by the application of batteries for the energy supply instead of the current diesel-powered vessels. That's one of the major contributions in this reduction. Furthermore, the vessel size reduces quite significantly, so that's also a contribution.
Very nice, very nice. Okay, I'm looking out in a question. Let me just tell you, Rolf, when you finish, you can go to the Q&A and reply to all questions that you feel, you know, that they are appropriate to what you to you and to what you presented, and they match to what you've described. An interesting question comes stating that, okay, how could we prove the increased safety of the mass? I mean, an immediate reply would be from all of us and all of you that we reduce the involvement of the human, we reduce human error, blah, 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 all that stuff. But is just this? Do we have something more?
It's a good question. Well, maybe it's already good to clarify a bit. I mean, the human error will be reduced in the end. But I also acknowledge that it could well be that there are some technical errors which will be in place. So it's not fully answering your question. I understand that. I also have not directly an answer to that, I must say, or an addition to that.
But it's a good reply, because it's not only the human, it's also the systems. The systems might change, the architecture, you know, redundancy issues. Many things can be different. So all this will deal and will contribute to the whole picture. On top of that, I guess we can go to operational envelopes, to business models. Everything will change. I mean, that's why I asked at some point Kostas whether you know an autonomous ship is just a ship without crew. I think that this industry, this example, this pattern in the industry can change a lot the industry per se and the movement of cargo. But thank you very much for your reply. And may I also ask what is your perception for your concept about you know, how do you see them advancing into the industry? Do you have plans? I mean, you said about the Dutch government about the alert, but the other one is, I think, what about the AGV? What do you plan about it?
Well, by coincidence, yesterday we also had an appointment with the Dutch government in relation to the development of a lot of wind farms in front of the Dutch coastline. And so there are challenges because of shipping operations, wind farms, solar farms. And so there is a lot of activity over there. So this kind of monitoring vessels, guard vessels, it's becoming more and more urgent. Also, it was mentioned that SAR operations become more complex, and because nowadays, where there is a lot of room for the SAR operators to travel to the sea, let's say, in a couple of years, there will be a lot of wind farms which they cannot enter or cross. So the time for SAR operations will increase. So perhaps the AGV as a solution for this kind of operations might also be possible.
Very nice. Very nice. Thank you very much. Thank you very much for your presentation and contribution. It was very, very interesting. I mean, having new concepts, new designs towards autonomous operation and autonomous ships, it's very, very interesting. Thank you very much, Rolf. So we are moving to the last but not least, this is a very cliche phrase, to Harvard Nordal. Okay. I understand that we have, you know, the time to keep, but we are expecting from Harvard a very, very interesting presentation on how autonomous will be and will the autonomous ships be. Harvard is a senior research scientist working in the Energy and Transportation Department at SINTEF Ocean. The department has several research groups, including the group of maritime ICT and cybernetics, in which Harvard works. This research group is and has been part of several national and international research and development projects within the autonomous shipping, perhaps most notably the Munin project and the Horizon project of AEGIS and Autoship. I know that you call it AEGIS, but AEGIS is the Greek word, so AEGIS. This has placed SINTEF Ocean into the center of development within maritime autonomy. Harvard's research is within the application of autonomy in shipping and implication on cost and emissions taxonomy and challenges related to uptake of autonomy, simulation, and modeling. Now, within and through his presentation, he will discuss that ships are much more expensive and move more slowly than cars. So the use of a remote control center is both economically and viable and practical way to implement autonomy in ships. Now, he will also be discussing about safe handover and avoid out-of-the-loop loss of situational awareness. Automation must be designed to alert the operator in time to take control safely. And this is what SINTEF Ocean called as constrained autonomy, and Harvard will explain this to us. So Harvard will also be discussing about terms coming from ISO 2386. So he will explain some and will give us some vocabulary terms related to autonomous ship systems. And we are very much waiting for this to be presented. Harvard, the floor is all yours.
Thank you. Thank you for the introduction. So today I'm actually stepping in for Ernulf Jan Rødseth to give this presentation on how autonomous ships be. And we can start this discussion by comparing an autonomous ship to an autonomous car. And there are two main groups of important differences between autonomous cars and ships. Firstly, compared to cars, the ships have high value, long voyages, and large crews, which makes it cost-effective to use a remote control center for the ship. But the same is not true for the car. Secondly, things happen slower for ships than for cars. So it is possible for the human operator in the RCC to take over control from the automation when this is necessary. That is, the automation does not need to be able to solve all problems, which in turn means that we do not really need full autonomy to realize autonomous ships. For cars, on the other hand, the reaction time to avoid collisions and accidents is too short to rely on handing over control to the human to solve complex situations. And these differences make it possible to consider practical realizations of uncrewed and partially autonomous ships assisted by humans, while the same concept is not possible for cars. So this is the essence for autonomous ships. Now, Colreg does not give direct instructions for what to do in every possible situation. So for some complex situations, it refers to good seamanship, which means it relies on communication between the officers of the watch. And this means that actions and future behavior depends on the human. And when we consider interactions between an autonomous ship and a conventionally crewed ship, it is generally not possible for an autonomous system to accurately predict what the conventionally crewed ship will do. This means that human assistance may be needed to solve complex situations for the autonomous ship. However, these situations develop slowly, so it should be possible for the automation to detect this in time to alert the operator, which means human automation cooperation should be possible in the case for autonomous ships. And this is basically why we believe that it's unlikely that it's possible to design fully autonomous ships today. But even though the autonomous ships will depend on the RCC operator for complex situations, a lot of the time there will not be much going on, which means that the automation can be in control for most of the time. So even though the human will be needed, there's still a great potential for reducing the involvement. And the idea of one person controlling more than one uncrewed ship, it's not completely unrealistic. But this also brings the problem of out-of-the-loop syndrome, or loss of situational awareness for the operator. And basically, the more you automate and the less attention the operator needs to give to what is going on, the more likely it is that the operator falls out of the loop. And this is a known problem for automation in general, and it's a problem that must be solved in the design of the human-machine interface. And the operator must be alerted early enough, and the information presentation must be designed to bring the operator back in the loop with sufficient time to gain situational awareness and to perform safe actions. And then when we discuss autonomous ships, it's important that we have a common understanding of what we are talking about. And one such common definition is given in the ISO TS 23860, Ships and Marine Technology, vocabulary related to autonomous ship systems. This is a technical specification, which means it's preliminary and it will be further developed. And it's been, the current version has been developed by ISO TC8 Working Group 10, involving around 40 persons. And it was published in April 2022. And in the following, we will take a look at a selection of a few of the important definitions. So firstly, what's the difference between automatic and autonomy? The ISO technical specification provides definitions for automation and autonomy, as we see here. And automation or automatic is defined as that automation can function without human control, but it is not known or verified under what conditions. And then autonomy is enabled by automation when the automation is designed and verified to function independently of a human as long as certain known conditions are satisfied. So in other words, automation enables autonomy, but autonomy adds additional requirements for the design and verification of the automation. Another important definition for autonomous ships is the operational envelope. And to give this definition, we first need a definition of a tolerable event. So a tolerable event is a technical or operational event for which there is a designed response that keeps the system within its operational envelope. That is, safe control and operation can be maintained. Then the operational envelope is then the conditions and related operator control modes under which an autonomous ship system is designed to operate, including all tolerable events. And I'll give some more details shortly. Then in the event that a situation occurs where it's not possible to stay within the operational envelope, a fallback state must be entered. And a fallback state is a designed state that can be entered through a fallback function when it's not possible for the autonomous ship system to stay within the operational envelope, which means the ongoing operation must be aborted. Okay, so to further explain the concept of the operational envelope, we can start by looking at the operational design domain as defined by the SAE. The operational design domain is the operating conditions under which a given driving automation system is specifically designed to function. So this is the process or equipment which is controlled by automation and the conditions for when the automation can be in control and trusted. Then for autonomous ships, the responsibility for controlling processes and equipment can be with the automation or the human operator. So the operational envelope consists of the operational design domain, specifying the processes and equipment that the automation can be in control of, and the conditions for the automation being in control. And furthermore, the operational envelope includes the conditions for when the operator can control processes and equipment. This means that it also defines when neither the operator nor automation can be in control of processes or equipment. And to mitigate such cases, the fallback space and the conditions for triggering a fallback is included. Okay, so then to the central question for this presentation. How autonomous do we expect ships to be? Well, not fully autonomous, at least not anytime soon. But some ship system processes or equipment will, under certain conditions, be controlled by the automation without human assistance. And enough so that uncrewed ships, supported by RCCs, can in time be realized. The operational envelope, which we just discussed, defines the autonomous ship system processes and equipment and the subset of these that the automation can safely control and the conditions for the automation being in control. And assistance from the RCC is then needed when these conditions are about to no longer being met. That is, the operational design domain is about to be exceeded. And at this point, the automation needs to alert the operator that they need to take over. Assistance is also needed from the RCC to recover from fallbacks. And fallbacks are initiated when the operational envelope is exceeded. That is, when a situation has occurred which the autonomous ship system is not designed to handle. And all of this boils down to that cooperation between automation and humans is required to realize autonomous ships. This means that we're talking about a new way for automation and humans to interact. It is a real cooperation where either human and automation can be in control, but not at the same time. And when the automation is in control, it must have full control, with or without human supervision. And an important aspect of this is that the automation must know its limits, and it must alert the human such that they can take over control when this is necessary. And this is what we call constrained autonomy. And this is basically the same concept as CCNR defines as conditional automation, and you can find it in some of the other autonomy level definitions that we've seen today as well. And as mentioned, when the automation is in control, it must be trusted to safely control the ship. This means that automation must be able to detect that it will not be able to safely control the ship and alert the operator in time for them to gain situational awareness and take control. This can be based on simple conditions, such as geographical position of ships, But normally, it would be better with an assessment of future traffic situations, which within some limits should be possible due to ships moving relatively slowly. And one way of quantifying autonomy level is then by time constants. And one such proposal is given in the paper Levels of Autonomy for Ships. And the paper defines two time constants. Firstly, TMR, which is the maximum response time, or put in other words, the time at which we can guarantee that the crew has gained situational awareness and are ready to act. Secondly, the paper defines TDL, which is the response deadline, or in other words, the latest point in time where the crew needs to be ready to initiate an action to avoid a dangerous situation. And then a system with the low response deadline translates to a low autonomy level and requires high attention from the RCC operator. And a system with a high and quantifiable response deadline translates to a high level of autonomy and enables unsupervised operations. So constrained autonomy is then possible when the automation system is capable of calculating the TDL, or the deadline for when the crew needs to act. Okay, so to conclude, there's a terminology proposal available in ISO TS 23860. Full autonomy is problematic, so we expect most autonomous ships to use constrained autonomy and to be assisted by RCCs. And this implies that automation and humans must cooperate, and that the automation must know its limits and detect when they are about to be exceeded. So thank you for your attention.
Thank you, Howard. Thank you. Very interesting presentation. I think it gave a very nice elements and terms, both in terms of operation, but also in terms of terminology. And this is very important because we must have a common terms and we must be able to communicate between us on a reliable way, because about autonomy, I've heard so many things. I've heard the term of autonomy used in so many ways. Also, the same goes with digital twins. I mean, it's everybody is using the terms on their own, under their own, rationale and way of thinking. First of all, let me tell you that one of the comments that I saw on the questions is SINTEF is a very interesting organization. Which is a very, very nice comment. May I ask you something? You mentioned somewhere a level of autonomy, and you presented somehow a scale. What do you think about the levels of autonomy that we are using currently at IMO? It's under discussion, as we all know. I think this will change. They will change. But what do you think? I mean, can they cover what we are discussing, what you were presenting, or they really need to be changed, really need to be, revised?
Yeah, so I only briefly mentioned this, and as I mentioned, there's a paper on this proposal that we made. And the reason is that we're taking the perspective of approval and how you can quantify levels. So this is why we've tried to find a way of being, say, formally explicit in what we mean when we say a certain autonomy level. And we feel that this is lacking in most proposals for autonomy levels.
Yeah. Clear. And you mentioned at some point, I don't know whether I really caught it well. You mentioned that it is impossible to design fully autonomous ships today. Did you say that, or operate? I mean, Can you elaborate a little bit on that?
Yeah. So this it relates very much to Colrex. So if we had rules that were possible to translate to mathematical expressions or easily implemented in code, then the picture would be different. But in Colrex, you have some terms that are more vague and needs human interpretation, and computers are basically not good at this. So it leaves some ambiguity for which is not, at least currently, not possible to handle for a computer.
Okay. Thank you very much. Thank you very much for your presentation. As I said, I found it was very interesting and very informative, because, as I said, to begin with, the basis is that we discuss with each other and understand what we are saying. So we should be using the correct terms and the correct way of using the words of this discipline. Now, we still have some time, so we can go to the Q&A. As I said, Harvard, this goes also to you. If you can go through the questions, and if you find some question that it is really of your interest and expertise, please go ahead and reply also in written. May I ask something? And I think that I will start with Carl. Carl, and I would like also the opinion of Kenneth on that. I saw a question about SCCW. I guess that if, as Harvard mentioned earlier, if we are talking about controlling or monitoring the vessel from risk control center, or a remote control center, or remote control operation center, the guys there, this is a bridge. If either we're talking about controlling one ship or multiple ships, is it a bridge? Are they captains? Do they have to be certified? What changes do you expect towards this end? So, Carl, please go ahead.
It's a very good question. If it's a bridge, I think it needs to have a life buoy on it, which indicates that maybe the current regulations for remote operating center is not 100% applicable. I think it's something they obviously have the same operational responsibility as a captains and crew on the bridge. So from that perspective, it should be treated very, very similar. Then I think there, as I said, there are a few rules that might not be entirely applicable for a remote control center that is required on a bridge. And I don't have a super good answer. I think this is one of the fun things that the world have to figure out together when we're getting to that point when the remote operating centers are being deployed, which is actually very soon.
Thank you. Thank you very much. Thank you very much. Kenneth, what's your opinion on that?
I would love to add on that. Do you know who loves sailing vessels? Captains. Do you know who hates sailing vessels? Crane drivers. If I could have a remote control center, I could get a hold of a lot more crane drivers if they don't have to sail half the time. So I would love that. That being said, obviously I see benefits from what Carl says as well. We can spread the best crew among a lot of vessels, where a great captain could do 3 vessels, just as a hypothesis.
Okay, thank you very much. And I see another interesting question here, and we have already touched upon, but I think it's a very important thing. So we get a question, how about the legal implications with respect to the hull and machinery insurance? How would courts interpret the competency of crew and due diligence required to perform the navigational duties? Would it be the AI to be blamed in case of an accident, of an incident happening during autonomous operation of these ships? Would the operator of the ship be considered as ship crew? Are we expecting a revamp of the laws associated with insurance and liabilities? Yeah, it's a big question, but I guess we all get the core idea and what our audience, what Mr. Gruel wants to convey. So I don't know. Let's start with Rolf. Rolf, I've also asked you that during your presentation. I mean, yeah.
Yeah, I can highlight a bit on that. I think that all in all, even autonomously operating vessels will still be under supervision of some kind of operator. And I would expect that such person would in the end be responsible for the entire operation. So basically, if any automation system is really in the lead, I still feel that this operator should be in control and have the liability in that sense. So that's, yeah, basically how I see it. Yeah.
Thank you, thank you. What about Carl and Kenneth? I'm asking Carl and Kenneth because I will go after to Harvard and Konstantinos, because you come from the industry part and you will be installing it and you will be using it. So yeah. So Carl.
Yeah, I think it matters a lot on which level of autonomy we're talking about. So our systems that I mentioned in our presentation are assistance systems. They're supposed to be the fallback scenario if they don't work is humans, the normal crew. So then of course the legal responsibility is still on the crew. When we're getting a bit higher up, where we start removing crew from the ship, especially if we get into the very far end of the autonomy level, when it's supposed to be no human interaction at all in theory, then it gets a bit more complicated, and I think the responsibility becomes more towards the technology.
Thank you, Kenneth.
Bit same as Carl, we kind of eagerly await the international forum to agree on what level we're talking about and what kind of laws we need for the different types of autonomous levels. For us, we're sailing internationally as well, so there's a lot of different countries and open waters, etc., that need to agree on all of this. I don't think we can take the lead as buyers of this technology, but we need to be a part of the decision, same as the ones creating the software or the technology can not lead either. So we kind of need to work together on and see where we're going. What kind of vessels are we actually dealing with? What will they be able to do? Will they have humans as fallbacks, etc.? And then the laws and regulations needs to follow.
Thank you. What about research institutes and universities? Harvard, Kostas, what do you think?
I'm not sure I have that much to add on, but so if you consider the concept I was talking about, there will always be, in my opinion anyway, a human involved. And as long as you're doing operations such as we will see in the first examples, like with the Yara Birkeland, where there's a person continuously supervising the operations, then I guess the question of liability is a bit simpler. But as soon as you want to go for operations where the operator is supposed to just leave the vessel alone and go ahead and do its business, and the operator is supposed to do something else, then I think it's a lot more difficult, because it's not so easy to expect that the operator will take the responsibility for what the ship is doing when he's not there. So yeah, I think that's going to be a challenge.
Costa?
Okay, I don't really have anything more to add. I mean, this is okay. It's pretty obvious that the current frameworks in terms of regulations and what determines liability and all of that need to change. Simply because the basic assumption that okay, there's always a human at the sharp end of the operation will not hold anymore for autonomous ships in varying degrees of autonomy. In terms of liability, I would agree that, okay, someone will be held responsible in the end, and possibly the operator would have to be that, entity, let's say. But in terms of insurance, I think it goes to, measuring the level of risk, because insurance is really about that, and determining insurance premiums and all of that, which is again very challenging, because if we're talking about humans, human error statistics are available, and the reliability of mechanical systems are available. But when we're talking about AI, that is not static, that is dynamic, it is learning, then determining the probability of error is much, much more difficult. So, yeah.
Yeah, Costa. Okay, let's take the human element from another side. I have a very interesting question or remark that the introduction of autonomous vessels would potentially result in reduction in manpower, subsequently resulting in unemployment for traditional seafarers who are not in the position to undergo the training required for working with these vessels or remotely from a remote operational center. I know humans have evolved with time to fulfill the needs of industry, but the question is about the pace of introduction of these technologies. Would the existing workforce be able to advance their skills and knowledge at the same pace? Has your organization or everybody who is working on that thought about just adjusting the pace with the demand and supply of this technology and of the relevant technologies? This is also a big question, but we have heard all of it, especially here in Greece and Southern Europe. This is very common, guys. We hear it all the time, and I would like to hear. I've touched upon, I think, with Kenneth and in one of the questions that I've asked to ask him, or to Carl. I don't remember, but can you? Let's start with Rolf.
Yeah. Yes. I already answered a bit.
With you, I touched that out with you. Yeah.
But I can highlight. I think the implementation of this kind of technology at this moment is not that fast. That it would outrun the pace of retraining conventional crew. That's my expectation. What I can imagine is that in the future, the current seafarers, at least not all of them, will be capable of making this transition to the new technologies which are being implemented. So I could imagine that some seafarers need to alter their function or their job in the end, which is of course not a very nice development. But yeah, I think it is realistic.
Thank you. Costa?
Yeah, I think that, at every stage, I mean, historically, where automation stepped up, increased, there was always the same trend. So initially, unemployment, then reskilling, retraining, and okay, after the first disruption, the system somehow, stabilized at the end, and there was some equilibrium. I think that the same thing will repeat here. And although, it is inevitable up to some point, we should consider the unemployment issue more closely.
Yeah. Carl?
Yeah, it's a question we're getting a lot also. Just as the previous guys said, it's not happening fast for kind of unmanned transition. I would go so far as saying that no sailing ship today will be completely unmanned. It's too much work to retrofit all that. So it's more the new builds, and it's a few percent of the world fleet replaced every year. It's going to take a while. In addition, there is actually already a shortage of seafarers, and it'll be even worse in the future. Fewer young people is attracted to that profession. With if you say more of a remote operator kind of profession, you will have something much more similar to a normal office job. You can go home to your family at night. So that is actually a benefit with this. Of course, over time there will be fewer that most likely is employed as captains. But I think that potentially the need for it is so the amount of people who wants to work with it might be smaller also. That's at least a trend we see.
Harvard?
Yeah, so I agree that the development is not going to be quick. So I don't think we'll see a big negative impact on the job market. And I think it's important to highlight is that, and I guess this depends on the region or the area that you operate in, but the lack of crew is a big problem, and this is the main motivation for what Japan is doing in this Meguri 2040 initiative, where they target to transform the Japanese fleet to 50% autonomous by 2040. And the main motivation is just to mitigate the problem with recruiting crew.
Yeah. Indeed. And they're recruiting Japanese only on their fleet. So yeah. Kenneth?
I can agree with Carl and Hova on this one. It could reduce some jobs, but maybe it will add others. We might see that we can operate smaller vessels with few on board instead of having a large one with a handful on board. And that being said, this is the discussion that's hard to conclude on before we know what we're doing, right? So it's the same when we cut the elevator operators, what will happen to them? We're talking about the same thing in the grocery store now. We've added a cash register that I can use on my own. Will then everybody lose their job? And as we've seen in the grocery aisles, they've now got more time to do other stuff in the store. So maybe we'll identify other jobs that could accommodate for the lack of sea personnel, but still that NCL could provide a lot of job opportunities for people. So I can't conclude on this. It could reduce, it could add. I'm not sure.
Yeah. Very nice. Very nice. I think, as I can see, we have concluded the time duration of this first day of the conference. I see that we haven't lost guys yet. No one from the audience. Everybody is there. So I take the chance and I will ask something more because I see on the Q&A continues repeating, subject, and this is of course is of cyber security. I mean. You cannot talk about autonomous shipping and autonomous whatever and not discuss a little bit on cybersecurity. So connectivity is one. The reliability of connectivity is one topic, but cybersecurity is an umbrella here that covers more things. So, Carl, can you elaborate? Let's start with you. This last tour of replies. Please,
Sorry.
emphasize, the importance of cybersecurity. I mean, yeah.
Of course, it's very important. We take it very seriously, and we're designing our product from the very foundation to be so-called cyber secure as much as possible. And we know it's not something you stop and saying it's done. It's a continuous updates and continuous struggle.
Yeah.
Our products are less sensitive currently because they're not really connected to the internet unless they need updates. So during operations, they're completely offline because we don't want to rely on potentially poor connectivity and similar, and we don't want to expose ourselves to cyber attacks. It doesn't mean that that means fully protected. There are other kinds of cyber attacks can happen, but we make it at least a little bit easier for us by doing it like that.
Rolf, are you with the concepts? Are you also working and dealing with this issue?
Well, basically, this is not really into our scope of work. In that sense, we focus mainly on the design of the vessel. Of course, it's in the back of our mind that this is one of the key risks of autonomy. So in that sense, I don't have really something to add to this, besides the fact that it's an important aspect to consider.
Yeah. Thank you, Rolf. Havard?
Yeah. So working in a group called ICT and Cybernetics, I guess I should know a lot about this.
Perhaps, I don't know. Yeah.
But it's not my field really. But what I can say is that if you're talking about attacks that prevents communication or makes the ship lose communication, then the system has to be designed in such a way that you can still maintain safety. So I think it's my understanding, at least, or my opinion, that the communication system cannot be safety critical in terms of if you lose communication, you still have to be safe. So this is of course for an unmanned autonomous ship.
Thank you, Howard. Indeed. Kostas, I guess you are the last to close the tour and close this Q&A, very interesting Q&A session. So give us your 2 cents on this topic, on this discussion.
Okay, thank you very much for choosing to end with the non-expert on this topic. Okay, what is interesting for me in this regard is, how, in general, how the impacts on cybersecurity and communications and all of that digital domain affect safety. And I think this should be the focus in future safety assessments to understand more about this relationship between cybersecurity and safety, because it is quite clear that one can impact adversely the other.
Yeah, I think this also goes also with software and how software is being, executed and all that stuff. With risk analysis and risk assessment, we haven't been dealing with all that stuff that are in the conventional way, on conventional ships, and this indeed will also play a very important role. Thank you very much, Costa. I think that here we can conclude our discussion, the first day of the conference of autonomous ship reality. I would like to thank once again the BS, the organizers of this conference, and of course Avicus and Seajob Naval Architects as the sponsors of day one, and Mass World News team for their media support. Thank you very much. As I see you, Havard, Carl, Rolf, Kostas, and of course Kenneth, who had to leave at 5 o'clock. So thank you very much for your contribution, for the interesting presentations, for the discussion, and hope to see you all soon. And we would also like to thank the audience. Thank you very much.